Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
I'm Elena. For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, nicely done. So, Elena, do you have a lot of social media?
No.
All right, well, neither do I. We
That's
just have our
fine.
producers take care of all that kind of stuff. So, where do you go to school?
Panama Elementary,
And what grade are you in?
4th grade.
How is fourth grade?
It's kind of early still, right? We're only still a few months
She's
in.
been in there for long
time.
enough. The first quarter's almost done.
I don't know.
It's all right? Nothing so great about it? You go to school longer now than you did last year, though, don't you?
I think
You should be going to school a little bit longer than you did last year, I hope.
That's
you
the
do.
rules. That's how
Right,
it is.
so I think you do. So, but it really doesn't affect you that much then if you're not even really sure about it, right? So it must seem that you enjoy school
a little bit.
a little bit. All right. So do you have a favorite topic or a favorite subject that you like to?
Math.
So you do. So you don't have to say math because you're on Do the Math, but you do like doing math. Good. So what kinds of things are you doing in class right now?
Double digit multiplication and division.
I thought you were going to say double dip, like you take 2 scoops of ice cream right there. I was like,
They
well,
do a
I'm
lot
right
of
along
food
with you,
work at that
sister.
Panama Elementary, I hear, yeah.
You know what? That's what they got going on over there.
That's
Then
right.
By all means, we'll go over there and check that out. But anyway, I think one of the things that you're going to be receiving today is ice cream from Sweet Fix. Have you ever been there? Oh, you're going to love this place. Wait until you go check that place out, all right? Are you ready to help me out with the social media problem of the day? All right, let's take a look at it right now. It's going to be up on the monitor. It says, what is an example of the commutative property? Now, earlier we were talking, and you know about the distributive property, and you know about the associative property. So do you know about the commutative property already, or have you heard about it, or you have? Okay. So when you see this 9 times 10 times 13, and you have those 4 options, what comes to mind?
Do 9 times 10.
Okay. And then, because tell me what you did with the associative property.
I would do 3 numbers and then put the answer and then the answer times the number and then get the answer.
Okay, and you know about the distributive property. So tell me about the distributive property a little bit.
You break it apart and then put it back together.
That's one way to do it, right? Break it apart and put it back together again. So commutative, you're just rearranging the order of them. Okay, think about their commuting, going from one place to another. So we're going to keep the same 3 numbers, 9, 10, and 13. But instead of leaving it in that order, we're going to do a different order. So which one do you think would be correct up there?
C.
Which one?
C.
C. Now, why wouldn't A be the same? Because it's got 9, 10, and 13 in it.
It's the same.
It's the same order, right? Okay. Now, we know that 10 times 13 is 130, so why wouldn't B work?
Because B doesn't have all 3 numbers.
It doesn't have all 3 numbers. Now, D, where do you think they're getting 23 from?
13 times 9.
Could be, but what about if somebody wasn't looking closely at it and they go 10 plus 13, do you think they might get 23 there? They could, right? But you're going to go with 10 times 13 times 9, correct? You feeling good with that? All right, let's take a look and see if indeed you are correct. All right, there you go. C is correct. First problem done, sister. See that? So now you've got the associative property, the distributive property, and the commutative property under everything's good, right? All right, very good. 6364357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. And in studio, we're fortunate enough to have a guest with us today. Eddie, how are you?
I'm doing great, thank you.
Nice to have you on board with us. You are an employee of the Kern County Superintendent of Schools office also, correct?
Proud employee.
Ooh, I know, you know what? I don't know if I've ever said, but nobody ever asked me where I work, right? So, but I also am a proud employee of KCSOS. So I'm glad that you said that. And is it because somebody's out there listening or something like that?
Oh no, I really love the organization. I love the culture.
Good. All right. Well, let's start there. How long have you been here?
This is my third year now. I'm the director for the HQIM department, and this is part of a large initiative that we're running with the California Department of Education.
Okay. And the thing that you got going on is the California Educators Together.
Yes.
So, kind of a little synopsis. What is that?
It's ultimately it's free resources for teachers. We have a lot of great free resources that are coming from large and reputable sources, nonprofits, statewide initiatives, and then we also have a ton of lessons created by teachers across the state.
Okay, so I as an educator can go on here and find lessons, and that's a free service for me.
Correct.
And if I wanted to contribute a lesson, there's a way that I could do that also.
Correct. We host lesson design institutes, workshops, and we also have an asynchronous course. And people who attend, or educators who attend our professional learning, create lessons. Those lessons get vetted by a statewide collaborative that we've also developed and that we work with.
Okay.
And then upon completion, they earn a stipend, and those lessons are up public on the site and available to educators across the state.
Okay, so it's across the state throughout California.
Correct. So we've hosted or held professional learning events as far south as Chula Vista and as far north as Glenn County. And then coming up in the end of the month, we're going to be out in Humboldt doing a lesson demonstration with a teacher.
Okay.
So we're really capturing all the corners of California.
Good. And I know that you said educator, so I'm assuming this is like TK-12, or does it go beyond that?
TK-12.
TK-12.
Yes.
All right, so that's for anybody in there at all.
Everybody.
I know some educators might ask this. Are there other languages available?
Yes, and if there isn't, the exciting part is that you can contribute those lessons. So we have a process where we do pay teachers to contribute new lessons by standards that we haven't addressed. And so if you see empty space in the platform, we encourage you to join the group, and let's make it happen.
All right, great. Well, you know what? Let's take a look at your presentation here.
So this is better. All right, so this is our California Educators Together guidebook. We have a few subject-specific guidebooks. We have a CTE guidebook, we have an ELA guidebook, but I'm going to highlight our science one for a second here. As you go through our guidebook, it's kind of like a virtual magazine. You could click on the different links. It highlights and showcases some of the resources that you'll be able to see. You could also see where we've interacted with participants or with educators across the state. This right here is a fantastic group of educators that we connected with out at LAUSD. I believe it was 77 educators at Bravo Medical Magnet. And then this here is a great group of educators that we connected with at the Contra Costa County Office of Ed. And then again, this is a presence that we've created statewide. Talking about pride in Kern County, we've also connected all across our county region. As you go through the guidebook, we are very intentional in being able to break apart what are the differences between the resources, the curriculum, and the groups that we have available for you on the platform. And then we also give you some tips for being able to navigate those resources. And then once you jump into the actual guidebook content, that's where for us it's really exciting. We showcase and share a sample of lessons created by teachers across the state. This one here, we're highlighting a local superstar, Holly Gonzalez, but you can click on any of those links and it takes you again to a sample of lessons. All the lessons that we have on the platform created by teachers have been vetted. They all have integrated ELD, they all have UDL, and they all have the free resources that you need to be successful in your class.
So before you go on, is there a way that somebody can look up a specific standard
Yeah.
and head that way also. Okay.
Yeah, you could go and you can search by specific standard, and then that actually speaks to the next part here on the
Well,
guidebook.
look at that.
Where
You know what? I'm going to come work for you, right? Put these things together, right?
This is your idea. We actually had somebody, I said, right, hey, listen, he's doing it. All right, put him on there now. So yeah, we have somebody put them on there in real time, but you can search by standard. You can find either resources from organizations who've contributed resources or teachers who've written that lesson for us. However, we also like to point out that we truly believe lessons don't happen in a vacuum. The lesson is a part of the community, which includes the teacher, the students, their experiences. And so, for example, this is Samantha Stickley. She's a fantastic educator down in the San Diego area, and she's one of 6 teachers who were honored with a presidential nomination by Tony Thurmond. And on the platform, you can get her lessons for free. You can watch her teach for free. You can get a podcast episode where she talks to you about what it means for her to be a science teacher and then how she starts her year as a science teacher. And you can get all of her entire curriculum from Open SciEd for free as well.
So this is something that if you are in your first year or first couple of years in education, this would be very helpful for you, because you've got other sources throughout the state that you can see in action. And even for somebody that's been in it for a little while, maybe a new twist on things.
Yeah.
You know,
you get some ideas, get inspired, and then just see what's out there. Again, we highlight teachers, different parts of the state. We're going to do a demo video here with Quinn out in Milpitas just in a week or so, and then more lessons, more local superstars. This is our Chelsea Lancaster doing fantastic work. Leah Thomas, a teacher who hosted an event for us. And this is what I really want to point out, because these to me are what make the platform special. We have kind of our heavy hitter initiatives that come onto the platform and bring resources. This is Climate in the Classroom through the Carbon Cleanup Initiative. And we have all of their lessons housed directly on the platform, integrated ELD, UDL, really solid cutting edge stuff. And it's led by one of our old and local teachers, Chelsea Lancaster. And then just to wrap it up, again, like really great resources, over 900 from Open SciEd available on the platform, everything you need for middle or high school, and then additional resources that we connect you to. For example, you got the Monterey Bay Aquarium, CAMS, California State Parks. Most teachers don't know, but they will actually do virtual field trips for you through their parks. And again, all of that available for teachers to be free. And if you see something there that's missing, I mean, we understand teachers have the labor of love thing going on, but we also pay for that work to be done and submitted.
Yeah, so just let you guys know, and then they can kind of put everything together, submit it to you guys check everything out, and then...
CaliforniaEducatorsTogether.org, and again, really proud for that work to be carried out here through KCSOS.
All right. Well, Eddie, thank you very much for coming in. That certainly was fantastic.
I appreciate
it. As a proud employee of KCSOS, I would like to thank you for coming in once again, because that's a wonderful resource. Like I said, for educators, whether they're brand new or a little bit seasoned and just want to try something a little different with the curriculum that they're already used to, you know, I mean, it's nice to freshen it up a little bit too, and find out what's new. As far as information and things like that.
Yeah, correct.
So, thank you for coming in and doing that.
Thank you.
636-4357 is the phone number. We'll be back with more right after this.
Hey, I'm Rianch, and I'm going to be solving for n today. To first start off, you have to do the parentheses, and you have to do 7 times n, which will get 7n, negative 7n. Then negative 7 times negative 4, which will be positive 28. Rewrite the problem. Next, you have to add the same numbers, or the same digits, like n and negative 7n, which will get negative 6n, and then 12 plus 28, which will be 40. Then you have to move the 40 to this side to leave the negative 6 by itself, and you have to minus by 40, and then minus 40 on this side. You'll get negative 42 and negative 6n. And then you divide by negative 6 on both sides, to get the n by itself, and you're going to get n equals positive 7. Thank you.
Another great example of solving for n right there. In studio, we have Elena, a 4th grade student from Panama Elementary. And as he was working through that problem, did you know what he was doing?
No.
That looked a little bit confusing, right? Well, guess what? We're going to make you do one of those. I'm only kidding. We're going to do something different than that, all right? Now, we were talking a little bit earlier, and you said that your lucky number is 7. But you're not really sure why you like 7 more than other numbers, right? All right, head on over to the board, young lady. So if we had 2 dice, right, each of them numbered 1 through 6, and you rolled both of them, what number do you think would come up the most often?
3.
3? All right, so just put a 3 over on the side. All right, that's your guess, okay? So what I'd like you and Devin to do is I'd like you to write down the possible outcomes. So the first one would be like if we rolled a 1 and a 1. Does that make sense? So maybe Devin will write down the combination. So we have a 1 and a 1. And then we would have a 1 and a 2, right? Then we would have a 1 and a...
3.
So help Devin get through these.
And
Okay.
a 1 and a 4.
So this is all of the possible outcomes if I roll a 1 first, and then whatever the second die could be. So a 1 and a 3, 1 and a 4.
A 1 and a 5.
Okay.
1 and a 6.
All right. So these are all of the possible outcomes if I roll a 1 on the first die and something else on the second.
And do me a favor, Devin, as you have the 1 and 1 up there, just
Right.
put what the outcome is when you roll it. So together we have a sum of 2, 3, 4, and down like that.
Okay. So these are all of the possible outcomes if we roll 1 first. What about if we roll a 2 first? What could happen with the sum of our second rolls? So we don't have to list all of the plus, but we can list now all of the possible sums of these two. So for example, 2 plus 1 would be what? 3. I'm just going to go ahead and put that over here, okay? What about 2 plus 2?
4.
Okay.
So what we're going to do is we're going to eliminate the 2 plus 1 because it would be the same as the 1 plus 2.
Okay. So I'm just going to go ahead and put a cross out through
Right,
there,
so we'll
right?
keep going from there.
So we would end up with, we're also going to have to cross out the 4 because that would be 1 plus 2 or, I'm sorry,
Well,
2 plus 2. Or, do we want to keep
Because
that?
now we've got 2 plus 2.
Right.
It's different than, because otherwise we didn't have a 2 plus 2 up there before.
Oh, I see what you're saying. So,
Right, now we're going to have a 2 plus 3, 2 plus 4, 2.
okay. So we're going to
So
make sure
1
we have
plus
something
2 and 2
unique.
plus 1 would be the
We
same.
can get rid of 2 plus 1, but we can add 2 plus 2 because you hear what he's saying? With the commutative property, 2 plus 1 would be equivalent to 1 plus 2. So this is a new scenario that we haven't had yet, and 2 plus 2 equals 4 here, all right? So let me go ahead and just erase what we've got there, get that out of the way. All right, let's go ahead and keep going forward then. We have 2 plus 3.
5.
Is that new? That's going to be 5, and that's not anything new that we have here. 2 and 4,
6.
2 and 5,
7.
and 2 and 6.
8.
And these are all unique. We haven't used any combination of 2 and 2, 2 and 3, 2 and 4 yet. Okay, let's take a look at our possible 3s. Now, do we have 3 and 1 or 1 plus 3?
Yeah.
Okay, we don't have to do that again. Do we have a 3 and 2? Or a 2 plus 3?
Yes.
Okay, we don't have to do that again. What about a 3 plus 3? Do we have any examples of that?
No.
Then we can go ahead and work off that. I'm going to go ahead and create some space over here for that. So we have 3 plus 3, and that equals
6.
6. Okay. 3 plus 4?
7.
I think we're starting to see a pattern where we could do this really quickly here, right? 3 plus 5,
8.
and 3 plus 6.
9.
All right, let's look at our 4s. And if I'm following the pattern right, we already have a 4 plus 1. We already have a 4 plus 2. We already have a 4 plus 3. So let's move it 4 plus 4.
8.
4 plus 5.
9.
And 4 plus 6.
10.
All right, I want to save this 3 that we had here, so I'm just going to go ahead and just fling that over there. We've got our 4s. We already have a 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4. So let's start off with 5 plus,
5.
and that
10.
gives us a 10, and 5 plus 6,
11.
and that brings us to our 6. We already have a 6 plus 1, a 6 plus 2, a 6 plus 3, a 6 plus 4, a 6 plus 5. What about 6 plus 6?
12.
Now, we see all of these potential outcomes and rolls. Let's see what numbers show up the most and the least. We have a 2 here. How many 2s do we have? How many outcomes of 2 do we have in all of these sets?
2.
I see 1 here. Where's another 2? Well, that would be a 12, right? So really, I only see 1, 2. But while we're here, how many 12s do we see?
1.
So we only have 1 12 and 1 1. We can kind of start working inwards on this, right? How many 3s do we have?
1.
How many 11s do we have?
1.
I think just 1, right? Okay. How many 4s do we have? I see 1 here
2.
and 1 there, so I have 2. What about 10s?
2.
2. Let's look at 5s and 9s. I have 1, 2, 5s.
2 5s and 1 9.
I think I see 1 here as well. 3 plus 6 and 4 plus 5. Oh, sorry, that would be, yeah, you're right. Let's get that 9 out of the way. This is a 2. It's easier than erasing. Let's try our 6s and our 8s. 1, 2,
3.
3. And our 8s are going to be 1,
3.
2, 3. Now let's see about our 7s. We had 1 plus 6. We had 2 plus 5.
And then 3 plus
We
4.
had 3 plus 4. So the numbers that are going to show up as far as unique combinations of digits that we can roll are going to be 6s, 7s, and 8s.
And if we took the other operations, like when I said don't do 1 plus 2 and 2 plus 1, the same thing, but if we went through all of those, you're going to get more of 7s, and then that
Right.
distribution is going to stay the same as it goes outward.
Right.
Right.
So right here, if we were to put this on a plot map and we stack all of these, it would look very much like a flat plane if we just use this version of it. But if we added all possible combinations, it would actually arc up like this. And this point, this peak, would be how many different ways you can get 7s by rolling 2 dice.
So a lot of people think, just like you do kind of, they think, oh, 7's my lucky number, because a lot of times it has to do with rolling 2 dice during a game or something like that. 7 is the most popular number because it has the most possible outcomes. If you didn't pick 7 as an outcome, what number do you think you would pick that would probably show up the most after that?
8 or 6.
Right, 8 or 6, right? And the farther you get away, the least likely that's going to come up. Does that make sense to you?
So
Good.
don't go with 12.
That way you kind of figure out a little bit why some people go, oh, 7's my lucky number. Well, it has more opportunity of coming up. For doing a great problem today right there, Eleni, you've got yourself a ticket to go see the Bakersfield Condors. So congratulations on that. And I do believe that season has started or coming up soon. Coming up. So it's October, so I know they start pretty soon. So you'll be able to go to any game that you like to with the Bakersfield Condors. We'll be back with more right after this. And once again, that phone number 636-4357. We do have phone tutors available most Tuesdays and Wednesdays available. I got that one out of there. Right? Most Tuesdays and Wednesdays throughout the school year. In studio with us right now, we have Matt, and I don't want to just call you Earthquake Matt. So where do you work, Matt?
I work at Cal State Bakersfield. I'm a professor in the Department of Geological Sciences, and you can call me Earthquake Matt because I study earthquakes.
Matt, there we go. All right, so easy enough then. All right, so how long have you been at the university?
I got here in fall 2020, so right in the middle of the pandemic. I moved here from the Netherlands, so it was a long trip, and I've been here 4 years now.
And in the Netherlands, were you doing anything similar to what you're doing at the university?
Very similar. I was in my postdoc, and so I was learning to make computers do earthquake cycle modeling.
Okay, and the classes that kids would be taking to learn about this would be?
Yeah, so I teach geophysics. So that's a class for majors. I teach a course in plate tectonics. That's for upper division students and grad students. And also one of my favorite classes to teach is natural disasters. And that's a GE course, a general education course at CSUB.
And what would that satisfy for kids?
That satisfies a science requirement, and so I like to, make sure we cover a wide range of hazards. I always start with earthquakes because I love them, but we've been having hurricanes recently in the East Coast, so I've been using that as my examples.
So you love earthquakes?
I do.
Not experiencing them, but you love studying them?
Exactly.
Well, maybe you like experience, but I mean, that way you get a lot of data, right?
Exactly.
Okay. Well, go ahead. I'm sorry.
Yeah, so actually, until I came to California, I always studied earthquakes from where they don't happen. So now I'm in California. There's a little bit of fear here now living.
So you've been here for 4 years now.
Yes.
And how many earthquakes have you experienced where you're at the place?
Yeah, I've only ever experienced one earthquake, and it wasn't even in California. It was an earthquake that occurred in Virginia, and I felt the shaking up in Pennsylvania.
Oh, okay. So you weren't here during, I think it was during the summertime. We had a little bit of activity here.
I was gone for 48 hours in Pennsylvania, and I missed it.
And that's when well, you know what? The guy from New York didn't miss it because when it happened, I was full alert when that thing happened.
Yes.
And the first time it happened was years before that, but I had no idea what to expect, going through that for the first time. So when we have an earthquake, what is happening underneath the earth? Because we don't see what's happening, like when you see a hurricane and other natural disasters. Earthquakes, we don't see.
Yeah, that's exactly right. Earthquakes are basically, in the earth, we have cracks between blocks of rocks. And an earthquake is just when that crack all of a sudden decides to slip. The two blocks slip past each other. It happens very quickly, abruptly, after years, decades, hundreds of years of slowly trying to move and not being able to. And then all of a sudden, in a couple of seconds, everything slips. Now, what's interesting is we actually do see earthquakes at the surface. So, for example, we know about the San Andreas Fault here in California, and we can see the last earthquakes on the San Andreas Fault did break up to the surface, and we can study that surface break to say what happened in those historic events.
So talking about slip, because there was somebody, I forget where I was reading this, but somebody was saying that, I don't remember the number of years, but at some point, Los Angeles will be north of San Francisco.
Yes. So on average, the San Andreas Fault divides the Pacific Plate from North America, and they move at about 40 millimeters a year or a couple inches per year. So you can, do that.
Won't be around, but
you can do that calculation. It'll take millions of years, but eventually Los Angeles, which is on the Pacific Plate, will work its way up north to be on next to San Francisco, which is on the North American plate.
Okay, and have you worked a lot with the Ring of Fire?
I do, yes. So we are actually part of the Ring of Fire, being on the Pacific Ocean. We have our earthquakes, but we don't have the volcanoes, which is where the fire comes from. But I do study what are called subduction zones, and they have the biggest earthquakes, they produce the biggest tsunamis, and that's where we have the biggest volcanoes. And I've studied subduction zones for about 10 years now.
Okay, so I'm sure a lot of kids are looking at this going, all right, what have you got here? So
Yeah.
what are we going to be doing?
This is a seismometer. This is what we study earthquakes with. Now, we use actually a lot of tools to study earthquakes, but this is one of our main ones. And so in here, we've got a little device that simply measures the motion of the ground. Okay? And so these wiggly lines you can see on the computer here, in fact, it's probably every time I tap this table, we'll measure the table moving. Okay? And so if we see a big signal, that tells us either the earthquake's really big, or it's really close, or both. And if we have a lot of these seismometers, and in California we actually have thousands of these instruments all distributed around the state, we can locate earthquakes, say where they happen to a really high degree of precision. We can say how big the earthquakes are, their magnitudes, and we can tell what type of faults they happened on.
So that brings me to my next point. Are there instruments that can help detect before, and I know it's going to be a very short amount of time, that it would alert you that, oh yeah, this is going to happen, and then a couple seconds later, bam, it's happening?
Yeah. The pipe dream, of course, would be to say an earthquake is happening tomorrow or next week.
Right.
We know that's not going to happen. This is a very complicated problem, and it's unlikely to happen. But when an earthquake happens, it produces a number of different seismic waves: fast, smaller P waves, larger, more damaging surface waves. And the P waves, if we can detect them ahead of time and say the earthquake is a magnitude 6 or a magnitude 7, we can warn people even before the S waves or the surface waves get to shaking. And that usually can give people about maybe 5 to 10 seconds of warning in a good scenario.
But at least you get yourself in a different situation to get yourself a little safer for when that does happen.
Exactly. This is the basis of the Shake Alert system, which is widely
coming up.
available. Yeah.
And I know because the school's going to be doing that, I would imagine it's a statewide thing.
The Great Shakeout, yes.
Right.
So California is very good at earthquake education, and we also have systems on our cell phones, and you can download an app, and if you're set up for the emergency alerts, you will get a shake alert during a big earthquake. So,
right, because I remember I got one on my phone, and I'm like, well, geez, no kidding, it didn't happen because I just felt it, right?
Yeah. This, of course, is the problem, is that if the earthquake is close to you, those P waves and the strong shaking get to you at the same time. That was one of the activities I did in the first week of class in my natural disasters class. We calculated how much time it would take for the shaking to get there. 7 seconds. That's also the same amount of time it took the computers to figure out there was a big earthquake.
Right.
Okay, so that didn't help us very much here.
So taking a look at the screen again, when you have some vibrations on here, so we can see, so what are the 3 different lines?
Yeah, so the 3 different lines represent the directions this table can move in 3 dimensions. So the blue line on top here, this represents the up and down motion of the table. The yellow line represents the motion of the table towards and away from me, and the pink line represents the motion of the table side to side.
Okay, so if we got this thing really going, so now we can see it coming through there.
Exactly. So you made your own earthquake on the table.
Yeah, well, we'll avoid those. So if somebody wanted to study this, and they're in high school right now, what are some things they need to get themselves geared for because they're like, hey, this sounds interesting, and I might want to get into this?
Yeah, it's really important to have a strong quantitative background. Math, physics, they really, really are important for understanding earthquakes. So when I was a high schooler, I was taking courses in algebra and geometry, then I was in pre-calculus and calculus, so, and I use those every day. My students don't believe me that I use all these tools every single day. I was writing something on the board and they said, how did you know that? It was something about the statistics I used to study earthquakes. And, you know, I literally do it every week, so it's second
something that
nature
you
to me.
use, right?
Yeah.
I mean, if you use it, it'll be second nature and
Exactly.
you're used to it.
Exactly.
All right. So once again, Earthquake Matt,
Thank you so
you
much.
for coming in. That was certainly informative, and hopefully you're in California next time we have one. That way you can feel it and feel a little better with that.
Yeah. Thank you.
All right. Hey, you know what? We'll be back with more right after this.
The electromagnetic spectrum is the range of all possible wavelengths of electromagnetic radiation, including the visible light that makes plants grow and the infrared that your remote control uses to command your television. Wavelength is one of the properties used to describe electromagnetic radiation, along with frequency and energy. Physicist Max Planck was the first one to realize that frequency and energy were directly related. For all you math lovers, it looks like this. Why does wavelength matter? because electromagnetic radiation can be used to examine multiple aspects of the same object. For example, when we look out into space, we might see something like this, because our eyes can only detect a small range of wavelengths. But there's a lot more information out there. The different types of radiation have practical uses too. High-frequency X-rays have very short wavelengths and enough energy to pass through our skin easily, but not our bones. And at the longer end of the spectrum are microwaves, which can have enough energy to heat our frozen dinners, but not enough to heat the walls of the microwave itself. So you can see that this electromagnetic spectrum gives science a whole range of possibilities.
All right, in studio with us, we have Elena, a 4th grade student from Panama Elementary, and now you have an idea of why 7 could be somebody's favorite number, right? If I said, I would like you to select a number between 1 and 100, what number do you think you would select?
76.
76, all right. And I'm not going to ask you why, it's probably just something that popped into your head, right? Okay, so 76. So I then, because we want to be the person that's closest to the number that is being hidden or whatever, right? So between 1 and 100, you're going to take 76. I'm going to take 75. So if the number is between 76 and 100, you win, right? If the number is between 1 and 75, who wins?
You.
I do. So I'm going to ask you again. If you could select a number between 1 and 100, would you like to stay with 76 or would you like to change it?
Change it.
What would you like to move it to?
55.
Ooh, that's a very good number, 55. Now, why did you go from 76 to 55?
Because it's in the middle.
It's in the middle, right? And that's what you want to do, right? Because then you have a better shot at winning. Does that make sense to you? Because hopefully you were thinking 76 to 100, I've only got 24 different shots right there, right? Yeah, old man, you got 75 different shots, right? Because I've got a larger quantity of numbers. So if somebody says, hey, let's pick a number between 1 and 100, you always let them go first, all right? And then you take the number on either side that is going to be more advantageous to you, all right? So here, we're going to select a number between 1 and 100. I'm going to go first, all right? I'm going to pick 8. So what number should you pick? Think about the one right next to it.
9.
What one?
9.
There you go, perfect, right? So 9, okay? So you now have 9 to 100, I only have 1 through 8. Does that make sense to you? So hopefully that'll come in useful sometime for you right there. But you are an expert at multiplication right now, right? Double digit? Head on over to the board, you and Devin are gonna work out a problem right now. So there are 1, 2, 3, 4, 5, 6, 7 people in here right now, and we have 3 females and 4 males. So let's make the first number 34.
Here, let's come down here. 34.
Times, and Elena, you get to select the next 2-digit number. And I don't want it 11.
Don't say 10 either.
All right,
28.
so go ahead and explain to Devin how to solve that problem.
You would do 30 times 20.
So you're actually going to start off here using the tens as the first thing you're going to multiply. Is it okay if I kind of write out each of those parts here over on this side? 30 times 20.
600.
600. You can go ahead and write there, I'll write up here. We can write at the same time. It's the 21st century. All right, so we did 30 times 20. What's the next part that we're going to do here?
20 times 4.
20 times 4. Okay, so you're going to do this 20 here times this 4. So I'm going to go ahead and write that almost like 4 times 20, just so I keep the order of the values in line. And you can go ahead and do the same thing. So what is 20 times 4?
80.
80. Okay. Let's go ahead and what's the next one we're going to do here?
30 times 8.
30, the 3 here and the 34 times the 8 from the 28. So this is going to be 30 times 8. All right, let's do 30 times 8. What does that get us?
240.
240. All right. And we're going to do one more here.
8 times 4.
8 times 4. So the 8 from the 38 times the 4, I'm sorry, the 8 from the 28 times the 4 from the 34. So this is going to be really more like 4 times 8 here, okay? 4 times 8 equals?
32.
32. So now what we're going to do, it looks like we have all of the different parts here. We did 3 times 8, 4 times 2, 30 times 20, and 4 times 8. So now we're going to add all these parts together, it looks like, correct? Okay, let's go ahead and add all of those. We have the 2 in the ones column, nothing to carry over or borrow. Now we'll add the 10s, the 8, the 4, and the 3. That gets us to 15. We bring 1 up top here. We have 1 plus 6 plus 2, and that gets us to 952. So the key with double-digit times double-digit multiplication, we want to multiply every combination of the ones place and the tens place together while maintaining the value of each digit.
Nicely done. So how are you with 3?
Good. A little
Okay,
bit.
so clear the board.
Let's go.
So let's see, today is October 7th, or is it the 8th? 7th? So
No, it's the 8th.
107.
Yeah. It's the 8th.
It's the 8th. Why do you shake your
Live
head?
television,
I asked you
everybody.
if it's 7th.
We're proving it, right? You have the newspaper to show that this is actually happening right now?
All right, so here we go. First number, 108 times, and you can come up with a 2-digit number. It doesn't have to be 3. You can do 2 if you like.
34.
All right, let's go.
Okay, so we've got a lot of combinations to work with here. What's the first one we want to try?
100 times 4.
100 times 4. And just what I'm going to do here is I'm going to go ahead and just circle the digits and their values so we can multiply them. So 100 times 4 equals what?
400.
400. Okay, let's go ahead and do our next set. What are we going to multiply?
30 times 8.
30 times 8. Let's do 30 times 8. We just did this. I feel like we did something very similar here, right? So what did we get with that?
240.
240. Let's do another set here. We're playing around with the colors just to make sure we're associating each of these parts here. What else can we try here?
0 times 4.
0 times 4. Now, let's go ahead and mark that we're doing this. This is really 0 tens times 4. Regardless of how many tens it is, what is 0 times 4?
0.
0. Some people don't even bother if there's a 0 involved, but I think it's helpful just to illustrate that we are paying attention to it. We know it's there. We acknowledge you 0, but you have no value to us at this moment. Let's go ahead and move to another color here. Let's find another set of values.
100 times 3.
100 times 30. Okay, and what does that get us?
3,000.
3,000. Excellent. All right, let's go ahead and go to our next set. What can we multiply?
100 times 8.
Well, I don't know if we would do 100 times 8 because they both exist within 108. We always want to multiply one from our first factor and one from our second factor. So what haven't we done yet?
8 times 4.
We can do 8 times 4. This way right there. 8 times 4 equals?
32.
32. Okay. Let's come up with another one here. Let's go gray on this one. What else have we? I feel like there's one more that we haven't done yet. Because if we have 3 on top, 2 on the bottom, that's 6 possible combinations we can multiply. So which one have we not done yet?
0 times 3.
0 tens times 3 tens. Absolutely. So this is 0 times 30, but just like when we did 0 times 4, it doesn't really matter what it is because it's going to equal what?
0.
By the way, we talked about properties before. This is the identity property of the 0 property of multiplication. Anything times 0 is going to equal 0. All right, so we have our 6 to add together, but really it's not 6, is it? It's only 4 because we can get rid of that 0. Well, we can get rid of that, and we can get rid of this 0 right here. So we only need to add those 4 together. So how might we do that? Do we have all the place values lined up? So this should be pretty simple to add. Let's go ahead and do so. So we have 2 in the ones, a 7 in the tens, another in the hundreds, that's going to be a 6, right? And then in the thousands place, 3. So 108 times 34 equals 3,672. And what I appreciate about this conversation, some people will try to keep order as far as doing the ones here times all the digits, and then the tens times all the digits. But you don't have to do them in any particular order as long as you're able to manage and track the place value of each digit. So nicely done.
Indeed. That was a great problem right there. We'll be back with more right after this.
What is the greenhouse effect? Earth is a comfortable place for living things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and a glass roof. The clear glass allows sunlight to shine into the greenhouse while also trapping the sun's heat inside. This is how a greenhouse keeps plants warm even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are all examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the right temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They've observed increases in the amounts of carbon dioxide and other greenhouse gases. The information from NASA satellites can help scientists figure out where greenhouse gases are coming from and how they are ending up in our atmosphere. This information will help us better understand the impact that greenhouse gases have on our climate, and help us better understand this very special greenhouse that we call home. Find out more about our Earth at NASA Climate Kids.
Anybody and everybody could be learning stuff from NASA. Have you ever been interested in anything about NASA? No? Well, maybe you will be now. Do you have any idea what an alligator lizard is?
No.
Nor do I. But guess what? We're going to have an alligator lizard in here tomorrow. Would it be cool if we had an alligator up here right now?
I would kind of be scared.
You know what? I kind of be
There'll be
scared too,
somebody
based on
bring the
whatever
lizard in,
size
right?
it
It's
is.
not just going to be released and then for
No. Well,
around,
see, because I think Cece's here tomorrow. I don't think you're. I could always
No.
change you. Could put you on tomorrow, whatever.
Whatever makes good TV. Let's make it happen. Here we go.
Oh, that'll make good TV. What about turtles? You all cool with turtles? All right, head on over to the board. You and Deb are going to play this game right now. So this is turtle sums. So what does sum mean in mathematics? You know what that word means?
Addition?
Right. So you and Devin are going to go ahead. The 3 and the 4 are on the left-hand side. You're going to be able to move, and you're going to put them where you think on that turtle shell so that they add to the correct numbers on the outside. And explain to Devin what you're doing and why you're doing it. All right, go ahead.
1 plus 4 because it equals 5.
Bring it over. Okay.
And then 2 plus 3 because it equals 5.
So you're able to make that distinction pretty quickly based off of what you have on these top two. And so you know that these have to equal 5 going down, and there's only one combination that will make that happen. And regardless of how we look at all these others, we know that those are going to be true because these two equal 5. So we can go ahead and hit the question mark and check to see if that's accurate. Very satisfying.
Bubbles mean good. All right,
Bubbles
hit the
are
arrow.
good.
Yeah, bubbles are good.
All right.
Keep going.
So now, we only have the 3 in place. And we have 1, 2, and 4, as well as all of these other solutions. Now, we're not just working down. We can see what that sum is going diagonally, across with some of these rows, as well as upwards towards that 5. So where would you like to start?
With the 1.
Okay, go ahead and grab the 1. Where would you like to move it?
Right here.
Okay, well, that makes sense because 1 plus 3 going across is going to equal 4. So that gives us the other 2 that are remaining. We have a 2 and a 4.
2 goes here because 1 plus 2 equals 3.
All right?
And then 3 plus 4 because it equals 7.
All right. So before we click on the question mark, do you want to check to make sure that everything else lines up?
2 plus 3 equals 5. 1 plus 4 equals 5. 2 plus 4 equals 6. 2 plus 3 equals 5.
So we can pre-check before we check. If everything looks clear to go, we can hit the question mark. We're back at it, 2 in a row. Let's move ahead. Now we've got 4 to figure out here. After we do this one, we're going to kick it up a little bit tougher. All right, so let's see how we do with this piece.
Oh, trust me, it'll progressively get going for you.
Let's let that kick up here. All right. How do you want to start off?
The 3 right here.
Okay, we'll put the 3 there. What makes you want to put the 3 there first?
Because 7 minus 3 equals 4.
Now we're adding, right? So we're doing, oh, I see, you're starting with the 7 and you're going backwards to get that other. So if you put the 3 here, then you're saying you want to put the 4 right there. Okay? Now, what can we try next? Or are we running into some challenges here? What is a challenge that you notice right now? Are you having difficulty making any of these other sums with what's left?
No.
No? So we have the 4 here. Something plus 4 is going to equal 4. 1 plus 4 is 4?
No.
No, right? What do we know? If we add it to 4 plus what will equal 4?
Nothing.
0, right? Do we have a 0 here?
No.
No, I don't think we can make 4 with a 4 in this column. But we know that we have to have the 4 plus 3 to equal 7. So is there something we can try?
Switch them?
Let's try switching them. Go ahead. So you may have to move that 4 into a spot first before you bring the 3 in. All right. Does that make our work a little easier then? Okay, let's go ahead and see what we can make happen from here.
The 1 right here because it equals 5.
Okay,
And then the 2 at the end.
great. We check all the way around. How do we feel about our choices? If you're ready to go, let's hit that question mark. All right. Now, I feel like you've got a pretty good hold on this structure here of the 2 by 2. Let's go up to the next level, 2 by 3. So we have 6 digits here, and we have fewer directions. But we also have 3 orange circles, and those orange circles will add up to a sum as well. So let's see what we can do with this setup. What are you looking at that makes you think about a starting move? Or what do you notice that will be helpful? Okay. Can I share with you something I notice? I notice that every single one of these columns equals 7. And so if I look at the numbers 1 through 6, I notice that there are only 3 ways to make 7. What are those 3 ways?
4, 2, and 1.
Well, let's start off with 1. How do I make 7 with 1?
6.
6. Okay, so I know 1 plus 6 is a pair to make 7. What's another way I can make a pair equal 7 as a sum?
5 plus 1.
5 plus 1 is 7?
Oh, no. 5 plus 2.
5 plus 2. And then what would the other one be then?
4 plus 3.
4 plus 3. So I know that those are the pairs I'm going to use. I have to use 1 plus 6. I have to use 2 plus 5. I have to use 3 plus 4. Now, there's another interesting part here, right? I know that these 3 across have to equal 14. If I need to make 14 with these digits, what do I have to use in order to get to 14?
6, 3, and 5.
6, 3, and 5, which is great because those represent 3 different ways in which we can make 7. I can have 6 here, so then what has to go here?
1,
I can put 5 here, so what has to go here?
2,
And I can put 3 here, and what has to go here?
4.
Now, I think we're in a really good position here. Let's check all of our things. This may not work, but we want to check and see if it does. So, do all of our columns equal 7?
That one equals 7, that one equals 7. So does that.
Good. Across, do we have a sum of 14 with 6 plus 5 plus 3?
Well, 6 plus 5 equals 11, and then plus 3 is 14.
Great. Now, there's 2 other things we need to check. We need to check if these digits equal 7, 1, 2, and 4.
4 plus 2 is 6, and then plus 1 is 7.
And there's one more piece. We need to make sure that the orange circles have a sum of 11. And we organize them over there to help with that.
6, well, 3 plus 2 equals 5, and then 6 plus 5 is 11.
All right, hit that question mark. Let's see if we're good.
I
Nicely
think we
done.
almost
All right,
done that.
young
That was
lady, come on
wonderful.
over here.
Nice work.
So, you've never seen an alligator lizard. So if you tune in tomorrow, you're going to be able to see an alligator lizard. Sound good? You are now an ambassador for Do the Math. Do you know what that means?
No.
You have to tell people about Do the Math. You think you can do that?
It's your job now. There's no way out of it. Sorry.
Yeah. So you've got a uniform and everything, right? You've got that shirt. So people are going to go, hey, what's that you're wearing right there? And you can tell them about the Do the Math program. Sound pretty good? Have you ever seen one of these?
Yes.
What is this?
A Rubik's Cube.
Do you do Rubik's Cubes? You pretty good at them? Have you ever seen one like this?
No.
See, this is an exclusive, right? No, not everybody has one of these kinds of Rubik's Cube. So you're going to be one of the very few, one of the ambassadors that has one of this, all right? So if I go like this.
Oh, no.
Do you think you can get that to where it has all Do the Math on it? Go ahead and try it.
Okay.
I have every confidence she can do this and do it in a record amount of time.
Are we? Did we get
you're
that?
almost there. Look at that.
Oh.
She's got it. Do the math right there on all of them right there. Nicely done. Pretty good, huh? All right. So, you remember the phone number for Do the Math?
Right
What
there.
is it?
636-4357.
There you go. And we're available Tuesdays and Wednesdays. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.